Hello everyone. So today we'll talk about Terraform tool. This is one of the tool we use more extensively in our DevOps uh, domain to create an infrastructure. So so today we will go through these things. Like first we will discuss about what is infrastructure as a code, then why there is a need of infrastructure as a code, then what are the related tools that come in infrastructure as a code, and what are the concepts in infrastructure as a code, and then we will talk about where exactly Terraform comes in your infrastructure as a code, and then we will start looking into what is Terraform, then what are the core concepts of Terraform, what is the life cycle of Terraform, how does it work, and then we'll have at the end we'll have a small hands-on session on a Terraform, like how to configure Terraform, how to use Terraform to create a simple EC2 machine on your AWS cloud. So that we will do it for today. So let's start first with what is infrastructure as a code. So as I written over here, like infrastructure as a code is the process of managing and provisioning computer data centers through machine readable definition files rather than physical hardware configuration or interactive configuration tools. So in a simple word, I would say like uh, IAC, we will talk infrastructure as a code as a IAC within our presentation and within our lecture. So IAC means to manage your IT infrastructure using configuration file. So let's think like let's suppose you are a part of uh, operations teams, and now uh, developers have recommended you, like insisted like developers have asked you to create 1,000 servers to deploy their application. So in that case, what traditional operations team will do, like they will go on their data centers, they will have some UI where they will able to access all those resources, and they will create one by one, manually they will create one by one those instances, which may take a lot of time, which may have a human errors because they are doing all stuff manually, like creating 1,000 servers. So instead of doing this stuff manually, which can create a what I can say, which can create a problem, which can create a error while creating it. So simply we can have some tool where we will write a configuration files, like we know, like some same like developer, we'll just taking example of developer. In developer, like developer writes some code and then they deploy it, and then we were able to see that application because of that code. So same we will be doing with this infrastructure as a code tool, where we'll have a code kind of thing where we'll be writing configuration files. In that we'll be mentioning, let's see, I want to create 1,000 servers, I want this specification, like I want this particular number of cores, I want this particular number of RAM on those 1,000 servers, I want to use this particular OS only. So this configuration file, if we write it and if we apply it to our data center, so it will automatically create that particular infrastructure, like whatever they have asked for you, like 1,000 servers, so it will create it for you. So same we can say, like infrastructure as a code means you can manage your IT infrastructure using a configuration files, and configuration files are nothing but you will have some kind of script where you will be writing like I want to create 1,000 servers, this particular CPU core will be used, this particular RAM will be used, and this particular OS will be used. So in that way we can go into deeper, but this is the higher level of any infrastructure as a code, where you can write a configuration file to create a infrastructure on your required data centers. Okay. uh, so why there is need of infrastructure as a code, right? So the first cost, like as I said, like if you are going to create infrastructure manually, creating an infrastructure for any application doesn't mean just you are going to create VM. There are several components you need to create, like network layer, then your infrastructure network layer you need to create first, then you need to create uh, interconnectivity between your network layer. There will be several components, like there will be a private network, then there will be subnets, then there will be a security groups and all. Then you create a virtual machine with the help of that network, and then you will be able to access that virtual machine. So if you are going to do these things manually, definitely you will need more resources in terms of mans. uh, I would say, like you will have to hire a specialized network team just to create a network for your infrastructure, then you will have another team just to use that network to create a virtual machine. So definitely it will incur a lot of cost, I would say, with respect to resources. Not just that, like you don't know like when how much infrastructure is going to be needed for your to host your application. So if you don't do that, so definitely you won't able to scale or descale in a runtime. So you will have to create a bigger si- uh, big in size resources for infrastructure. And because of that also, that definitely will incur a lot of cost. Like let's suppose like you have created a 16 core and 16 core and 64 GB machine, and your application is not needing that much resource right now. Definitely when there will be load, definitely you will be needing that, but that you don't know right now. So in that case, you are already creating some bigger infrastructure that is not going to be used 100%, not 100%, I would say, at least 90%. Definitely that will incur a cost. So that cost is the first parameter we pointing out. Because of that only we will need an infrastructure as a code. So there we will have a minimum team which will able to write a configuration files, and through configuration files only, that particular team will able to create a network and plus infrastructure as well. Plus, because of configuration files in a runtime, we can create a infrastructure, we can delete that infrastructure without any human intervention. So cost is the thing. Now the second we already discussed, that is scalability and availability. So when we talk about scalability, so we talk about that part only, like your infrastructure should scale in a runtime. Like you don't need to create a higher resource infrastructure at the first point only when you don't know how much uh, load there will be on your application. So gradually with experience you can scale up your infrastructure. So that can be done through your configuration, that can be done through your infrastructure as a code. So in that you can, in a runtime you can change your flavors. Like right now you have 8 GB and 16 RAM machine. Now you know like this machine is not capable to uh, support a load which we are getting on your application. So definitely uh, you just have to simply change the core size and RAM size in your configuration files and reapply it. So that it will automatically delete older instances and it will create a new instances for you with a new resource sizes. So this is how you can scale and descale what your infrastructure. Inconsistency, like when we do manually and when we talk about 1,000 servers we want to create, definitely there will be inconsistency. There might be a chance you must have used same like let's suppose in your team there are 4 members and those 4 members have got a task to create 1,000 servers, so they must have divided 250 each. So it is not like they will stick to same resource size and same OS. There definitely there will be some inconsistency while creating a uh, VM with particular resource or with particular OS. So to avoid that inconsistency, there is a need of infrastructure as a code. So now we discuss why there is a need of infrastructure as a code. First is cost, then scalability and availability, and inconsistency. Okay. So what are the related tools that comes in infrastructure as a code and concepts in infrastructure as a code? So don't think like infrastructure as a code means uh, you are just creating a infrastructure for you. It contains lot of, it contains different tasks, I can say, right from creating your infrastructure, then configuring your infrastructure, uh, and configuring your infrastructure to deploy your application, and then deploying your application, right? So these are the three tasks of your infrastructure as a code. So it's not just you will be creating infrastructure only, but it consists of three different tasks. One is creation, infrastructure provisioning and management, then configuration of your provision infrastructure, and deployment of your application. So in that several tools comes like Ansible, Terraform, Puppet, Shape, CloudFormation, and so on. So we can think like so right now I said like Ansible and Terraform. We already talked about Ansible in our previous session. Like why Ansible we use this, that is for configuration management. Okay, so when we talk about configuration management is nothing but we write a set of tasks in a yet markup language format in Ansible. It's kind of playbook, and we apply that playbook on remote machines where we want to uh, install. Let's take an example like Nginx we want to configure. So we'll have a set of tasks to configure Nginx, like installation of Nginx, then configuration of Nginx, and then then starting Nginx. So these are the three tasks we will be we will be executing on our remote machine. So this is the part of configuration management, and for that we use Ansible, Puppet, and Chef like tools. And to create infrastructure, we will be using Terraform. Mostly cloud formation is specific to AWS cloud only, but Terraform is generic one. We can say like it can be, they have almost provided a lot of providers, so we can say like almost every cloud is covered by Terraform. So you can simply use Terraform to create infrastructure on any cloud you want, like AWS, GCP, DigitalOcean, your data centers as well. So definitely you might have got question like why there are so many different tools. So if we are talking infrastructure as a code, we'll have a three different tasks like infrastructure provisioning, then configuration of provision infrastructure, and deployment of application. Why can't we have just a single tool? So the answer to this, like, each tool cannot do everything. Definitely each tool will be a great in that specific area. We will, if we talk about Ansible, that is, the Ansible is too good to do configuration management because of several models are available, a proper documentation is there, right? But you might be not good at creating infrastructure, right? So Terraform is good at creating infrastructure, but not suitable for configuration management, right? So infrastructure as a code is not related to single tool like Terraform. It consists of three different tasks like infrastructure provisioning, infrastructure provisioning and management, then configuration of your provision infrastructure. That's nothing but you'll be deploying some application over there, and then deployment of your application through another tools. You can use Jenkins as well. Not a Jenkins, Ansible as well. Sorry. So you got my point. What I'm trying to say here, like infrastructure as a code consists of several tools like Ansible for configuration management, Terraform for infrastructure provisioning, okay, and so on. Okay, so where does actually Terraform comes in infrastructure code? So we already talk a lot about this slide in our previous slide, right? Now we know like infrastructure as a code consists of three tasks like infrastructure provisioning, and then configuration of your provision infrastructure, and then actual deployment. So now we know like where Terraform comes in to provision infrastructure and to manage infrastructure. To manage infrastructure is nothing but you can descale, upscale, descale. You can destroy your infrastructure in runtime with the help of Terraform. Okay, and the configuration of infrastructure uh, to deploy application and actual deployment application will be a part of your Ansible machine. So now you know like where Terraform comes in IIC at infrastructure provisioning and infrastructure management. Okay, so now let's come to Terraform. So now we understood like what is why Terraform is being used, where it comes actually in your infrastructure as a code. So Terraform is an open source infrastructure as a code tool developed by HashiCorp. So HashiCorp is the company uh, who is having several products like Terraform, and there is one HashiCorp Vault as well. So in latter sessions of our DevOps training, definitely we are going to talk about HashiCorp Vault. But currently we will talk about Terraform only, which is the code tool, which is infrastructure as a code tool developed by HashiCorp Vault. So it is used to define and provision the complete infrastructure using an easy to learn declarative language. Okay, so same we talked about, there we will have some configuration files. In that we will write everything like this much, this many servers I want to create, this particular flavor need to be used like 4 core and 16 GB RAM machine, and this particular OS like RHL or CentOS should be used. So same Terraform it's used to define and provision the complete infrastructure using easy to learn that declarative language. So declarative language is nothing but there will be a configuration files which will be in the form, which will be using a declarative language called, okay. So it is an infrastructure provisioning tool where you can store your cloud infrastructure and set up as codes, okay. So so it does orchestration, not just configuration management. Like you can orchestrate in a runtime, like you can scale, upscale, descale, and everything. It supports multiple providers such as AWS, Azure, GCP, DigitalOcean, and many more, okay. It provides immutable infrastructure where configuration changes smoothly, okay. So because of it is using configuration file, so your infrastructure will be immutable. it's not like one uh, it's not like if you create a infrastructure, so you won't able to change it after that. But Terraform gives you the flexibility to make your infrastructure immutable, so you can do changes smoothly in a runtime. And as I said, like it uses declarative language, which is easy to understand. So that is nothing but HCL, that is HashiCorp configuration language. So in our demonstration, you might be seeing .tf files. So Terraform will have those configuration files with extension .tf. So if you have a .tf file, the Terraform will be able to read that file, and it will create a infrastructure according to configuration written in that .tf file. So that is nothing but your HashiCorp configuration language. So it is again in-house developed by HashiCorp only. They are using that only, which is simple and declarative language, I would say. Uh, Terraform supports client on architecture, so need for additional configuration. Sorry. So Terraform supports client only architecture, so no need for additional configuration management on a server. So what does it mean? Like uh, you don't need to configure uh, anything configuration management tool on your server. It will be just a client, Terraform client will be used, and that client will be used to create whole infrastructure for you. So you don't need to do additional configuration just to use your Terraform. It's a simple binary file. You just have to use that. It will do everything for you. You don't need to do much more apart from that. Okay, so while doing hands-on, so you will come across these core concepts of Terraform. So I just wanted to let you know about this few core concepts like variables. So variables are used as input variables. So it is a key pair value used by Terraform modules to allow customization. So you can parameterize your configuration files. Like you will have a configuration file. Let's take an example. Like you will have a one configuration file. In that you have mentioned some flavor. Like let's take an example of AWS. You might know there are flavors in AWS like T2 micro, T2 dot medium. So you can parameterize that part. Like you can pass that particular value as a in a runtime with the help of variables. So you can define input variable, and Terraform will ask you in runtime only like what flavor you want. So you just add. You just have to add that variable, and it will automatically pick that particular value uh, to create infrastructure in your Terraform. Provider, it is a plugin to interact with API of service and access its related resources. So provider is the main thing, I would say. Like if you want to communicate with any cloud or data center, let's suppose you want to create infrastructure on AWS. So provider will be a main part where it like technically as I said, like Terraform just gives you a client, which is a simple binary file. So you don't will not have any configuration related. So if you want to create an infrastructure on AWS cloud, so we'll have to use a provider. So there are commands like we will definitely go through the Terraform life cycle, like what we do, like whenever we create an infrastructure, that is Terraform init, Terraform plan, and Terraform apply. So Terraform init will be the command is to download all the resources uh, required to create an infrastructure on that particular cloud. So that particular cloud is given in the provider section. I will show you how provider file looks like. Same will be for other resources as well. So whenever we will do Terraform init, it will automatically download all those resources and configuration files needed for that infrastructure creation on that particular cloud. Module, it is, so now you got what is provider. Module, it is a folder with Terraform templates where all the configurations are defined. Okay, so as I said, like we will using some simple, easy to use declarative language that is nothing but .tf files. So .tf files we can treat them as a modules. Okay, so we'll have those Terraform templates which will have extension .tf, and in that we'll have all configuration to create that particular infrastructure. So those are nothing but your modules. Like let's take example like in AWS, if you want to create a EC2 instance, so EC2 is nothing but a module which will be used to create your infrastructure. Okay, next is state. Like it consists of cached information about infrastructure managed by Terraform and related configuration. So the Terraform, why we use Terraform, why we able to uh, why why we say that Terraform creates immutable infrastructure, why changes are done smoothly because of Terraform, why that is because of state. Like Terraform maintains the state of your infrastructure, it stores the state of your infrastructure in a file called state file, and that is only used to do further activities. Like if you want to do some changes, it will automatically compare with that state only, and it will update, it will apply those newer changes to your infrastructure, and again will capture that state into the state file. So state file is, I can say, um provider and state files are the main part of your Terraform working. It can be a, we can say it as a core of your Terraform. So state files are used to maintain the state of, to capture the state of your current infrastructure created. Okay. Resources, like it refers to a block of one or more infrastructure objects. Like we already talked about models, in that we talked about EC2. So that EC2 will be a model, and that EC2 will have a resources, right? AWS instance creation, there are several resources. So that resources will be used to create uh, your actual infrastructure. Okay. So compute instances, like in AWS underscore instance is one of the resource will be used to create EC2 machine. Virtual networks to create VPC. Okay. Data source, it is implemented by the providers to return information on external objects to Terraform. Okay. So if you want to return some information on external objects, so definitely you can use Terraform. Output values, there are let's suppose you have created some resource, EC2 machine, and you want IP of that EC2 machine. So with the help of output values, you can easily print the IP of your newly created EC2 machine using Terraform on your terminal. Okay. So we just talked about Terraform lifecycle, that is Terraform init, plan, and apply. So plan, uh, it is one of the stage of the Terraform lifecycle. It is one of the stages where it determines what needed to be created, updated, or destroyed to move from current state of your infrastructure to desired state. So now you understood why we talked about state. Like it maintains your current state in a state file, plan reads the state file, and then determine like whether you want, like if it is, if we are creating infrastructure for the first time, there won't be a state file. So automatically it will create a plan, like whatever you have mentioned, like 1,000 servers I want to create. So it will show you like this is how 1,000 servers will be created, and that will be a plan. And once you apply that, if you use the command Terraform apply, it will apply that plan. uh, it will apply that plan, and there will be changes on your cloud, and those 1,000 servers will be created, and that particular state will be again stored into state file. So the next time you want to do changes, now right now you have created 10,000 services, and now you want servers, now you want to create 1,500 servers, and if you change that number, so it will check what is the current state. Right now there are 1,000 servers, and now what should be the desired state? There should be a 1,500 servers. So it will compare with the help of that state file, and once you apply it, it will create more 500 servers for you to reach the desired state, where there that state files will have uh, state of 1,500 servers. Okay. So these are the core concepts of Terraform, I would say. So we already talk about these things like Terraform.state file, which will have a data which will consist of the current state of your infrastructure. In TF-vars, like TF-vars, you can mention variables. You can mention variables in form of uh, key and value pair. Provider.tf file will be there, where we will be mentioning what provider you want to, like let's suppose you want to create infrastructure on AWS, so that provider will be mentioning in the provider.tf. And Terraform instance.tf, like it's not like there should be a proper naming convention. Whatever file which will have a extension .tf, Terraform will be able to read that. We just to visualize things, we have added names like this. Like Terraform instance will have a code to create an instance on your AWS cloud. So we already talk about this plan like Terraform init, plan, apply, and destroy. Like you already know about what is init. Like in initialize, it downloads all configuration files from internet. Like if you provided as AWS, so whatever resources needed for uh, infrastructure to be created on AWS, so those will be downloaded on your current working directory where you are applying Terraform init. Terraform plan will create an execution plan to reach the desired state of your infrastructure, and changes in the configuration files are done in order to achieve the desired state. Okay, so now you got it. What is plan? Like if you hit Terraform plan command, it will create an execution plan. Let's suppose right now you don't have any infrastructure, so it will create an infrastructure plan. There is no infrastructure. Infrastructure. This is the current state. What is the desired state? I want to create 1,000 servers. So it will create a plan for you. Like this is how 1,000 servers will be created, and this will be, and those will look like this. You will be able to see like what resources it is going to create, and then if you hit Terraform apply command, so whatever plan that have shown from your last command, that is from Terraform plan, it will it will apply to that cloud, and it will create an infrastructure and will come to the desired state from current, that is there is no infrastructure, to 1,000 servers. Okay, and if you want to destroy uh, your infrastructure, so you can simply use the Terraform destroy. With the help of that state file, it will able to uh, fetch all those details related to your infrastructure you created from Terraform, and it will delete everything. So this is the Terraform lifecycle, I would say. So how does Terraform work? So Terraform has two main components that make up its architecture. Okay. So Terraform core. So Terraform core uses two input sources to do its job. You already talk about there will be a configuration files in that will be writing, or will be in that will be rewriting your all your configuration to create require infrastructure, and second will be a state file where Terraform will keep the current state of your infrastructure, and which will be used further to do to do changes in your infrastructure. So this is a Terraform core, and the second part is providers. We talked about providers as well. So the second component of the architecture are providers for a specific technology. This could be cloud providers like AWS, Azure, GCP, or other infrastructure as a service platform. So with the help of providers, you will able to download all those required resources from internet using the Terraform init command, and you can use them further with your configuration files. So how does Terraform works? So you can now visualize like we will have a TF files in that we will have a configuration written to create some infrastructure. We'll have a Terraform core in that uh, the Terraform core is nothing but part of Terraform configuration files on your Terraform state, and it will use your providers configurations to create an infrastructure. So this is how Terraform work. So now we can think like the situation before Terraform was so hectic. Like application team used to request infrastructure creation to IT team. The IT team used to take a lot of time just to create infrastructure on the data centers, and again giving back that infrastructure to application. So this was incurring a lot of time, lot of cost, I would say. But because of Terraform like tools, so it made easy for everyone. Like in a runtime, you can create a infrastructure for your application team, uh, and you can do anything. Like you can smoothly changes everything because of these templates uh, provided by Terraform to create infrastructure on any desired cloud you want, like AWS, GCP, Alibaba, uh, DigitalOcean, and so on. Okay, so so now what we do, like we will start doing hands-on. Let me just a wait. Huh? So now, what I did, like I have already like to work with Terraform. Like today we are going to do hands-on with the help of AWS Cloud. So recommended prerequisite things to do hands-on is to have a AWS account with administrator access for you. Then some jump machine, like either it can be Linux on your local also you can do installation. But I will show you a demo with the help of Linux machine which I have already created. So in that we will be configuring Terraform, and that will be used further to do hands-on. Okay. So to do installation, simply you can search it on Google like install Terraforms. It will land you to this official page, and here you can select operating system you want. So currently I have already my machine. So let me show you what. So basically this is Amazon Linux machine only. Like I have used Amazon Linux OS. So you can go into Linux, and here you can select what is your machine. Like I have Amazon Linux. So these are steps so simple to do. Like you just have to copy and paste it in your environment. So you can see like for every operating system they have given a steps. You just have to select your required OS and just copy those steps into your machine. So as I have Amazon Linux, so I'm directly going to use those steps. So now you can see Terraform is installed. You can check Terraform with Terraform command. If you hit it, see it's a simple client. I would say you didn't do anything. Like you don't need to install any dependency just to run Terraform. It's a simple binary file. It is now installed in your bin directory, and you can access it from any user, like just not just a root user, but from your non-root user as well. Let me show you that as well. Like if I do Control D, now I'm into my non-root user. If I do Terraform here, this is so simple to install. Okay. Now let's search for providers. We'll talk lot about providers, right? So you can see providers as well. Like if I do providers in Terraform. So if I click on this is again a official. We will look into official documentation only. Here you can see there are so many providers available, not just cloud but other tools as well, like Consul, DNS, local, Nomad, Vault. Okay. Okay. But today we are going to do hands-on on AWS only. But as I said, like we can configure anything like AWS, Azure, Google Cloud Platform, Kubernetes, Alibaba Cloud, Oracle Cloud Infrastructure, OpenStack also is there. Like Azure Stack, we have it. Okay. Uh, okay. Not just that, like you can create your customized configuration as well in Terraform. So you can see like there are 2883 providers available. Now you can see what is the power has Terraform given in DevOps domain. Like you can do infrastructure as a code with anything. I would say like see. Okay, sorry. Uh, so coming to AWS cloud. Okay, so this is again a public cloud. Uh, and they have. Now let's check user provider. So this is how, uh, here only you can get content of your user provider. Nothing, we don't need to mug up anything. Like if you want to create a particular EC2 instance, just follow Terraform's official document. So it will give you exact code. You can use that code. Like if I want to create a provider, so we talk about provider is nothing but it is the essential part of your Terraform core where it will download all the resources required to create infrastructure. So let's begin with hands-on. So I'm just what I'm doing, like I'm just trying to copy. Now I hope you are able to see my screen. Just zoom in a little bit. Okay. So what I do, like I will create one directory over here first, mkdir terraform demo. Okay. Now I have inside that, I will go inside the Terraform demo. Now, as I said, like we will have a one Terraform will read only .tf file. So whatever file you will be creating, you will have to give extension of .tf only. So just to segregate things, we can write everything into a single Terraform TF file, but we will create a separate files like to for a provider.tf provider. So I will create a provider.tf file, and here I will be pasting the thing configuration which I have copied uh, from the what I can say from that official document. Okay. Okay. So now let's see like what it does. Now you can see if I do ls-lrts, there is no file. There is only single file provider.ts. Now we have already added our provider, that is AWS. Now we want to download all those resources available for that AWS cloud on our local machine to use them further to create infrastructure on any AWS cloud. So if I do Terraform init, see, so we are using latest version of Terraform provider is v version 4.55.0. So if I do ls-lrth, so ls-lrth, so you can now see like they have created one .terraform file which was not earlier before applying the Terraform init command. So we have executed first command of Terraform lifecycle, that is Terraform init. Because of that, it able to download all those required resources for that AWS with the help of that provider which we have provided. So this is hidden to us, and if you go inside Terraform directory, you will able to see all the providers information. We don't need to worry about these things. Like this is transparent to us. Uh, okay, so it has already downloaded everything for you. Let's just go outside. Okay. Now, so required providers are downloaded. Okay. Now I want to use it. Okay. So there are several regions in AWS. We already know about that. So I want to create an infrastructure in a specific region only. So I will have to use this provider AWS block. So in that block, I will have to write like this: region equals to US East 1. And you must be thinking like, how I know? Like, I'm not doing any out of the box. This is all given on internet only. If you search for, wait a second. So if you go here and if you click on, not like that. If you search for AWS provider Terraform and just click on this first URL, here you can see like we already used this part. Again, we are using this provider. Like here also they have mentioned region. Like same you will have to do. Like what region you want to use to create your infrastructure, you will have to mention like this only. So I didn't do any out of the box. This is already available on available in their document, and that's it. Okay. So the next thing is like, uh, this is just the thing like you have initiated, you have downloaded resources, but how you will able to uh, connect with your AWS cloud? If your account, so you'll have to connect to that account, right? So how you will be able to authenticate your AWS cloud account with Terraform? So there are several methods like, along with region, we'll have to specify these two things like access key and secret key. My access key and secret key you will have to create. So if you go on your, like I have already my AWS account. Okay, so if I want to, like this is the DevOps gigs is my this is a user account for this particular AWS cloud, and I want to create a keys, programmatic access keys for my account that will be used in my Terraform. So here I will go on a search tab. In a search bar, I will see, will search for IAM. So there are no users. You will have to create one user. Okay. So click on add users because this is my root account. So there will be no user for this root account. I'll have to create another user. So click on add users. Give username as a Terraform demo. Okay. Then click next. Wait. Terraform demo. This is a plain newly created account. So there are no groups. There are no users. So I'll have to create a group as well. So what I will do, like I will create one administrator group, admin group. So this particular user will have all access to my AWS cloud services. So I directly give an administrator access only for a sec, but you can definitely you will have to secure your users like, uh, because we have to deal with cloud. So definitely there should be some access control levels. But for sake of time, I'm directly giving administrator access to my that user. So now I have created a user admin group. Now I will add that user in this admin group. So that particular user will have all administrator access. We'll give a name like some Terraform. The user is created. Now user is created. Now go to security credentials. And here is the option to create an access key. So that particular user will have programmatic access to authenticate with AWS Cloud. So if I click on create access key, so there are several options. Just a minute. So let's simply select command line interface only. Click on next button. Just a moment, guys. Uh, Tag value is optional. So let's create access key. So see, the access key and secret key is created now. Okay. Okay. We'll have to copy it somewhere, then only we'll be able to use. So, but right now I will directly show you like how we can use it. Okay. So there are multiple ways like you can directly hard code your access key and secret key in provider section. But again, in DevOps, like we learn about Git or GitHub in our last sessions, right? So definitely as a DevOps also we are going to maintain our Terraform file somewhere, somewhere nothing but some source code repository only. So in that case, it will be insecure to hardcore your access key and secret key directly in your TF files. So what we will do, like we can go for another option that is export. So this can be used. So we will use this. You will try to export our AWS access key and secret key with the help of this command. So if I copy it, now I'm trying to paste it over here, and now I will be copying my access key from here. Okay, same I will do it for secret key. Reason is already there in our uh, provider section, so we don't need to export that. Okay, so this is done. Okay, now let's try to create a simple resource. Like we have already example, I would say. Let me show you example. Okay, nothing I am doing. I don't need to remember anything. I'm just simply create a VPC, create a S3 bucket. Let's create a S3 bucket using uh, Terraform in our AWS account. Simply searching it, it will be redirecting us to that official document only. We came over here. Now if you scroll down, so now if you want to go search for a code, so here you can see example usage. They have already given it. Okay. Now I want to so the resource name, this is also human readable, easy to understand. Like if AWS S3 bucket is the resource name, so definitely it will be used to create a S3 bucket only. So now let's create let's just copy this and use and try, and if see like if this particular buckets get created or not in our AWS account. So we'll just copy it. So this is the resource, and you should give some meaningful name to resource. Like they have given B, so definitely whenever you will be going to write a complex Terraform scripts, there will be involvement of several components. Let's suppose uh, if you want to, if you are going to create auto scaling group, okay, so definitely auto scaling group will need some load balancer to distribute your load in that auto scaling group instances. So your load balancer should be created after uh, so your load balancer should be created first and then auto scaling group should be created. So in that case, once your auto scaling group will be instance will be created, it will automatically gets added to your LB. So in that case, you if you want to connect two resources, two different resources to work together, so we should you will have to give some meaningful name, so that meaningful name will be used further. Like let's suppose another example, like in EC2, uh, there are several components needed to create a EC2. Like let's take example network only. So to have EC2, you should create a VPC first. So if you use a VPC resource, so if you want to use a VPC resource which you have created in your EC2 instance in a Terraform, so that particular resource name, that is nothing but this B, that will be different one for that VPC resource that will be used to connect to that particular EC2 resource machine. So naming convention should be proper, and you should give proper names to your resources to distinguish between them. Okay. So again, now we have provided a TF file over here. Now we will create one s3.tf, which will have our code that is to create a S3 bucket. We just simply copied it. Okay. Now save it. Now do Terraform init again. We have already configured our AWS key and access key with our machine. Now we are doing Terraform init. So it has again initialized. Now if we do Terraform plans, it will show us what is going to create. Now current state is there is nothing created. There is no access S3 bucket. But in Terraform, it will show the plan is going to add one S3 bucket uh, in the AWS cloud. That is the desired state. Like with the help of that, it will be creating one S3 bucket. Now you can see over here like what kind of S3 bucket is going to create. See. So the environment will be dev name will be in my bucket. With the name of this, it will create a S3 bucket. So now let's apply these changes. So right now also you can see like there is no state file is created, right? Because we are creating infrastructure for first time. So there won't be a state file. Current state is blank. So if I do Terraform apply, it will you will have to give only yes. If you give other than yes, it will discard your changes. Yeah, because we are creating public bucket now, so it is already available. We'll have to give some unique name. So let's change the name of our bucket. So now you can see like you don't need to go on UI just to check whether that particular name is available or not, right? It will automatically search for you and it will show you like, yeah, this is not available. Please change the name. Please give a unique name because we are going to create a public bucket. So my TF DevOps gigs bucket. Let's see. Now let's again do Terraform init. Then Terraform plan. And now Terraform apply. So you already understood the life cycle of Terraform. Terraform, you need to initialize the resources to be used to create required infrastructure. Terraform plan, it will show you the plan, what it is going to do on that particular cloud. Like, is it going to add resources or is it going to modify resources or is it going to destroy resources? So, and then Terraform apply to apply those changes. Let's type yes and click on enter button. See, Now you can see apply is completed, resource one is added. Okay, now let's go back to our AWS cloud and let's search for S3 service. Let's go into S3. See here you can see our S3 bucket is created with the help of Terraform. So this is how Terraform is your work to deal with any infrastructure. Okay. Now the last part of DevOps lifecycle is Terraform destroy. So with the help of Terraform destroy, now let's say after apply, you can see state file is created. So if you open this Terraform state, so you will able to see like it created one S3 bucket and it maintained the state of that particular infrastructure over here. Okay. Now we want to delete that S3 bucket. So you don't need to give a specific name. Please delete this S3 bucket. Uh, it will simply look into terraform.tf state file only. What are the resources are created? It will simply delete everything. So terraform destroy, if this is the command. See, now it has searched for it look into state file and it found there is one infrastructure created, that is S3 bucket, and it now after applying terraform destroy command, it is showing us like this will be deleted. And if you want to delete it, type yes and click on enter button. See, your resource is deleted. Again, go back to your AWS cloud and just refresh your page. You won't see your S3 bucket is deleted now. Same you can do several things like we just uh, look for S3 bucket. Now let's suppose we want to create a EC2 machines. So here you can simply search as well like EC2. Not that way we can set like here is a documentation, so you can find almost every service from AWS cloud. They have TF files maintained. You just have to simply use, and you have to apply logic in a such a way like what infrastructure you want to create. You will have to apply logic. I will show you one Terraform script which I have written. Okay, so you can come here and you can search for EC2. Sorry, Elastic Compute Cloud resources. Sorry, why it is not going? Sorry. Let's search directly on internet. See, this is the registry.terraform.io file. This is the official document for all your resources. So we landed over here. Click on examples. Click on complete. We'll go to examples. Where are the examples? Yeah, see. This is so simple. Like model name is EC2 underscore instance. So you can use this and you can apply it. Let's apply it and let's see like whether it works or not. Otherwise, I will create for you. Let's not do this example. I have one example. Okay. So let's create one EC2 instance. Okay. Um, we'll create one EC2 file ec2.tf, and in that we'll try to write resource. This is so simple example, I would say. Like if you want to create instance, so AWS instance will be the resource will be used to create instance. So again, you will have to give some meaningful name like DevOps gigs server. Okay. Now we will provide AMI. Let's find AMI from our Google only. Let's use same AMI which we have for our Terraform machine. So let's come back to EC2. So this AMI we will use. Let's copy this AMI. Okay. Instance type t2.micro. Okay. Just a moment. Okay. Instance type we have given. Now we want to give a key name. Like I have already created one key, so we are going to use same key. Like if you go in keys section, you can create a key pair in runtime as well. Like let me show you that as well. Let's do that way. Create a key pair using Terraform in AWS. Just search for it, it will get it for you. See. So if you have created your own key, so let's do one thing. Like I will get this key. Let's create a key first that we are going to use to in our newly created instance. So here you can see, let me just give some key pair. This will be our resource name, and our key name will be DevOps key. Okay. And public key, you might know like how we can create, like we can use SSH keygen to create a public and private key. Okay, let's do that as well. Uh, so the command will be ssh keygen -t rsa. We are going to use RSA algorithm to create our key. So here we will give name like DevOps RSA. Okay, sorry, something. No passphrase, no passphrase. Okay, so now you can see like our PEM file and public key is created. Let's copy this public key. Let's open DevOps RSA.pub. Okay, simply copy this key. So this key will be used to create a key resource in AWS. Okay, let's go back to our ec2.tf. Simply replace this key. Let's add our key. This key will be created, and we have already PEM file to access our instance. Now let's give key name in our instance. Okay, how we can give that key name? I hope you understood what I'm trying to do. Let's just copy this key name section, paste it over here. We have key name given like that is DevOps key. So DevOps key will be used. DevOps key. Okay, let's close this. Okay, so now we have everything. Let's try to run Terraform in it. Oh, something is wrong. See, every time we'll have to do init because then only it will able to fetch resources. Like right now we are going to create key pair and EC2, so it will initialize those resources for you. Then do Terraform plan. Let's see how whether it works or not. Now you can say there are three changes going to be added. One is S3 bucket we already deleted, so it is again there because there is a TF file. Then your key pair. So this one, okay, and your instance. Okay, let's apply now. Let's see what happens. Let's type yes and hit enter button. So now you can see creating S3 bucket, creating instance is creating, but your key pair is now already created because it's a small resource. S3 bucket creation is also done. Now it is trying to create a DevOps server, DevOps gigs underscore server for you. Let's go back to our AWS Cloud Console. Look for EC2. See, here it is trying to create that resource. See, this is also created. Now let's try to access that newly created server with our key. Just copy this particular. Let's see whether security is open or not. Yeah, it is already open. So if I do SSH hyphen I, this DevOps RSA key, this is nothing but PIM file. And to see the username, just click on connect, click on SSH client. Here you can see EC2 user is the key. Okay. So EC2 user at the rate, and that IP we already copied it, right? From your public IP we copied it, this one. Okay. Now let's just paste this cop ID and hit on enter button. There must be some security. Let's go into security. Let's check for inbound rules. I have opened traffic for now. Let's just to see. We are able to connect it. So Terraform is really simple to use to create a complex infrastructure you want. Okay, let's now delete our infrastructure. We don't need this. So again, Terraform destroy will be the command. Now you can see like in S3 bucket that is also captured. Sorry, in state file. See, everything is captured. So it will use this same file only to update your infrastructure or to destroy your infrastructure. So if I do Terraform destroy, see, now it is showing like 3 to destroy. 3 resources are created, all 3 will be deleted. So it is trying to delete that particular server. Sorry, key is already deleted. S3 bucket is also deleted. See, everything is. Let's go back to our EC2 machines. Click on instance running. Refresh it once. See, your instance is already deleted. So this is how Terraform helps you to create your infrastructure in runtime. You can scale in, scale down. You can destroy. It will definitely reduce your cost to create infrastructure. It will be really scalable and efficient, highly available, right? And your infrastructure will be consistent throughout because of there is a minimal, not a minimal, I would say like just to write configuration files, but there won't be any human intervention to create your infrastructure manually. So that's it from my side.